Our next topic this week is risk and return part 2, and this is portfolio theory. So these are the subtopics that we're going to go over this week and in preparation for understanding diversification and portfolio returns, efficient portfolios, looking at risk-free assets, looking at the CAPM model, and summarizing a little bit. So what I want to look at first is the diversification. And I'm looking through one of these models and just looking here, one of the interactive models, this gives you a portfolio that you control how many stocks, and it just kind of draws a number of stocks based on that. It gives you a different set every time. The red line is it's basically, the red line shows the cumulative return of the equally weighted portfolio of 20 stocks. So let's see there. So the return is basically showing you how much is the portfolio grown over 5 months. Okay, so this is like 50%, 100%, almost it goes to 200% here of its original value, 100% return, right? And what we want to see though is where does the portfolio, what happens when you have more stocks? So when you have more stocks, notice that it actually doesn't matter so much for the total return when you're just about underneath. Once you go below 10, that's what it really matters. It changes quite a bit. Okay? So play around with this and also look at the correlation, because once you say you reduce the correlation to 0, it kind of makes you gets you into a straighter line, as opposed to if all the stocks are correlated to each other, you actually are just getting to the average, because it's almost like as you invested into that one stock to begin with. So it gives you, the lack of correlation gives you less volatility. And that's ultimately the goal of the portfolio, is to have lower correlation between the stocks so that you have less volatility. You still have the returns, but less volatility, okay? And as opposed to, higher correlation, you have higher volatility, and ultimately the volatility, it converges exactly to what your return is. This is very interesting. Definitely encourage you to look into this further. And next thing, we're going to look at risk-free asset. Looking at the risk-free assets, what are we looking to do when there's a turn? There's so much focus on the returns, we have to look at the risk ratio as well. And with the risk ratio, we really want to see what's the ratio of the return to the risk. Return over risk is the Sharpe ratio. And that's what tells us if we're actually doing a good balance, a good ratio between risk and return. And ultimately, a great investment is an investment that is risk adjusted, of course. So, looking at this kind of shows you a portfolio of asset A and B, F and A here. And you could be 100% A, okay, in which case your risk is 14.5, okay, and your return is 4.5. So you're taking a lot of risk for that 4.5%. As opposed to the more you go to just the other way, you're going to go 0% A, 100% F, risk-free, and you have 3% return, okay, because the risk-free rate. And the more you go up, you start taking on that risk, how much more return you're going to get. What is your Sharpe ratio? What's your return over the risk, okay? And that is what we want to be watching. Is, the more, oftentimes you want to take more risk, you want to have a higher return, but at what cost is that? Okay, so that's kind of, you want to look around and understand what are the risk adjusted return. The other idea that we're going to look is using the CAPM model, which is essentially looking at what is risk-free rate, what is a beta, And essentially this formula that is used to estimate the cost of equity of a firm, which talks about the risk-free rate plus beta, and then the market risk premium minus the risk-free rate. So essentially, the cost of equity of a firm is, you have to start with its beta. How correlated is that stock to the actual market, say the S&P 500, and then looking at what is the market risk premium of the S&P 500. I believe it's traditionally about 7-8%. Then subtract the risk-free rate times the beta plus the risk-free rate. And that is essentially giving you the cost of equity. How do we arrive at this? Why is this correct even? Because one may say, hey, let's look at the entire variability, the entire average return of the S&P 500, and we can say what is the expected return of the S&P 500? Well, over the last 100 years, that's been about 7%, 8% above the risk-free rate, so about 10% total. So you could say, oh, well, if the stock is exactly like the S&P 500, it would be about 10% total. But that's why if we adjust the risk-free rate, which is the variable each year is different, we adjust the beta, how correlated is the stock to the S&P 500. Essentially, we're using the S&P 500 as a base and then tagging the risk-free rate and tagging the beta on there to kind of go backwards to an individual stock and the current time period in order to derive the actual cost of equity.